Okay, so suppose we've just done a bunch of work in simplifying an expression. Let's say we've just simplified this expression, and we think that the simplified form ought to be 2x squared minus 14x minus 30. The claim we're making is, no matter what x is, no matter what number x represents, these two expressions evaluate to give the same number. How can we know that for sure? Well, we could, by hand, pick a bunch of x's and try plugging them in. And after we get the same value for a whole bunch of x's, we might expect that they're the same for all x's. But that is a time-consuming, tedious process. We know someone that's really good at time-consuming, tedious processes, and that's our calculator. Now, the technique I'm about to show you will only work as long as there's only one variable in your expression. And the reason for that is the calculator only knows about one variable, and the calculator thinks every variable is called x. Okay, with that limitation in mind though, this is still really convenient. So let's run through the steps of using the calculator to check that simplification we talked about. Alright, to get to a place in the calculator where you can enter these expressions, hit the button labeled y equals. As you can see, we get this whole list of y's, y1 up to y7. If you have a slightly newer calculator, you might see slightly more y's than this on screen. We're going to take this and we're going to enter our first expression as y1, and we can enter this just the way we see it on screen. Notice this button that says xt theta n, we use that to enter our variable. Exponents, use the regular exponent buttons. Once you've entered it, take a minute and read through and make sure you've entered everything correctly. Then go on to y2 and enter the second expression. And again, take a moment and read through and make sure that you've entered that correctly. Now, we want to look at a table of values. To do that, we'll hit the second key, and then do you see the button at the top right labeled Graph, and above it in blue the word Table? If we hit that after we hit second, we'll get a table of values. And the thing that we notice, looking at the calculator, is that all the y1 and y2 values are actually different. This tells us that we must have made a mistake in simplifying that expression. Uh-oh. What should we do when we find out we made a mistake? Yeah, you're right, we should go back and try again. Let's try that. First we'll write all the subtraction as adding the opposite, and now we'll apply the distributive property to eliminate all the parentheses, and we'll have this expression. And now carrying out multiplication and reordering the terms so that like terms are next to each other. And finally, combining like terms, we'll have 3 plus negative 2 is 1, plus 1 is 2, x squared, plus negative 14x, plus negative 16. And finally, rewriting plus a negative as subtraction, 2x squared minus 14x minus 16. Notice that that's different from the answer that we had before. we found the constant ought to be 16, not 30. Looking at the table again, now we see all the y1 and y2 values match. So these are probably equivalent. Notice, you don't see every possible value of x. Even if you scroll up and down, you only see integer x's in a table like this. So it's possible that by accident, your expressions could agree for all the x's that you happen to look at. But you would have to get really unlucky for that to happen. Assuming that you aren't really unlucky, if all your y1 and y2 values match, that tells you that your expressions are equivalent.